This is Gail Kovac for Gresham Barlow School District. This is summer school, high school credit recovery, Algebra 1B, and learning target number 12. I can simplify expressions using the power-to-power property of exponents. So this is somewhat related to learning target number 11, just multiplying variables that have different exponents and realizing, oh, we just need to add the exponents together. But now we've got powers to powers. And again, I'm going to go with when in doubt, expand it out. So in this case, we happen to have a parentheses, and outside that parentheses is an exponent of 2. That means it's not just this a here that's being squared, it's this entire thing that is being multiplied to itself twice. 4a to the third power times 4a to the third power. So let's expand that out. That's going to be 4a cubed times 4a cubed. And oh gosh, what do I actually do with this? Let's see. I'm going to expand it out. This is going to be 4 times a times a times a times 4 times a times a times a. We multiplied 4a to the third power times itself twice. Now this looks familiar. I think I can just group all the things that are alike. 4 times 4, that is 16. And I got a whole bunch of a's. Let's see how many a's I'm going to have all together. 1, 2, 3, 4, 5, 6 of them all together. So let's see what actually happened here, because this is your answer. But if we didn't want to do all that multiplying out, all of this work, if we just want to go from here to there, what could we do? So this exponent of 2 here is basically getting applied to every single member inside of this group. It is being applied to the 4 squared, and it is being applied to the a component, a cubed squared. So it's like you've got 4 squared, and then you've got 3a to the third power squared as well. And this would be 4 times 4 is 16, and this would be a to the third power times a to the third power. And we learned before that all you have to do is add those exponents together. This is 3a's multiplied, that's 3 more a's multiplied, that's 6 altogether. So in fact, what you're doing is you're multiplying this power to all of the powers that are inside. This is 4 to the first power. It now becomes 4 to the power of 1 times 2, or 2. This is a to the third power. This now becomes a to the 3 times 2, or a to the 6th power altogether. Oh, did I write 3? Oh, that's a mistake. You're probably looking at that like, what? What's going on? That doesn't make any sense at all. Yeah, you're right, it doesn't. That should be 6 a's altogether. Thank you. All right, so let's see if we can apply that here now. And I might need to expand it out because I got something weird going on with a little 0. So one important thing to note is that an exponent of 0 means that you are multiplying none of them together. It's your multiplicative identity of 1. So anything, and I'm going to write this in a special color, and I'm going to make it big and bold. Here's a rule. It's anything to the power of 0 is 1. Something important to remember here. That's multiplying something 0 times. That gets you your multiplicative identity, which is just 1. Because anything times 1 is itself. All right, so let's use this power rule to apply this exponent here of 4 to both members of this term in this group right here. So remember, this is 4 to the first power. I'm going to multiply that power of 4 to each of the powers inside. So then we will get 4 to the power of, and let me write it like this, 4 to the power of 1 times 4. That's its power. We're also going to have r to the power of 0 times 4. So 4 to the power of 1 times 4 is 4 to the power of 4. Exponent is 4. And 0 times 4 is 0. All right, so 4 times 4 means 4 times 4 times 4 times 4. And I can actually do that in my calculator, which I'm going to do now. 4 times 4 times 4 times 4 is a big old number. It's 256. So this is 256 times anything to the power of 0 is just 1. R to the power of 0 is 1. 3 million to the power of 0 is 1. Negative 10 to the power of 0 is 1. A unicorn to the power of 0 is 1. Anything, any number to the power of 0 is 1. So that becomes times by 1. And, oh, look, my variable is going to drop out. There's going to be no more r's that I'm multiplying to itself. You're going to get a grand total value here of 256. No more r's because they were to the power of 0. So important things to note here. When in doubt, expand it out. If you can't remember all of these rules, that's okay. You can kind of derive them by just expanding it out and going, oh, we needed to multiply the powers. I get it. That's going to be your fail-safe no matter what. And important to note that anything to the power of 0 is equal to 1. You'll see lots of those problems.